Hello everyone, so in this video we will be discussing complex numbers. So complex numbers, it is a number that takes the form a plus bi, where a is called the real part and b is the imaginary part and I is the imaginary unit. So basically a is the constant number or the real number. We also have the b, which is also a number, but with the imaginary part, and we have the I as our constant imaginary unit. So in this case, we will be discussing the operations of a complex number. So we have here the guide on the operations on complex numbers. We have the addition of complex numbers, in which you just have to add uh, if given a plus bi plus c plus di, you just have to add the constant numbers and add that one with the imaginary parts or the imaginary numbers, and we have the imaginary unit. The same goes with the subtraction of complex numbers. We just have to add, or we just have to subtract the constant numbers or the real numbers, and we have to subtract as well the imaginary part, and we have our imaginary unit. Now for the multiplication of complex numbers, it is just basically a distributive property, or by FOIL method you can find the answer or the complex numbers or the product of the complex numbers by FOIL method or distributive property. For the division of complex numbers, you have given a plus bi divided by c plus di, you just have to multiply that one with the conjugate value of our denominator. That is, you have to multiply that with the reversed expression or with the reversed operation of our denominator. So as you can see here, this is plus, or this is positive, meaning to say you have to multiply that with a negative uh, conjugate. So we have c minus di all over c minus di as well. And then perform the operation or perform multiplication for the numerator and the denominator. So that leads us with this answer. So now we'll move on to the operation of our examples of the operations of our complex numbers. So we have here first is the addition, or perform the indicated operations, then simplify the result. So as you can see here, this is an addition of complex numbers, and this one is the subtraction of complex numbers. So we'll answer number one first. So to answer number one, again, you just have to add the constant numbers and add the imaginary parts and then copy the imaginary unit. So that being said, this is equivalent to 2 plus 4 plus our imaginary parts, which are 3 and 7. And then we have our imaginary unit, which is I. So that is equal to 6 plus 10 I. So basically, it's very simple. This is already our final answer. Now for the subtraction of the complex numbers, we have here 24 minus I minus 10 plus 3I. So that gives us the constant numbers. The same process with the addition of complex numbers, but different in sign or operations to use. So meaning to say we have 24 minus 10 plus negative 1 minus 3. Why minus 3 when in fact this is plus 3? You know, since we used positive here, we need to uh, reverse the sign of our 3. So that if you multiply that one, that will still give us negative times positive, that is negative, right? So we also have our I, or the imaginary unit. So 24 minus 10, that is equivalent to 14. And then negative 1 minus 3, that is negative 4. Negative 4 times positive, we have negative 4. And then we have the imaginary unit, which is our I. So this is now our final answer. So now we will be moving on to the discussion of the multiplication of complex numbers and division of complex numbers. So we have here perform the indicated operations and then simplify. So we have 2 plus 3i multiplied by 5 plus 7i. So basically just apply FOIL method or distributive property. So we have 2 times 5 plus 2 times 7i plus 3i times 5 plus 3i times 7i. Then basically just perform the operation. So we have 10 plus 14i plus 15i plus 21i squared. I'm sorry, this is squared. This should be squared. Now, as we know in complex numbers, I squared is automatically equivalent to -1. So that being said, we have 10 plus 14i plus 15i plus 21 is multiplied by -1. Again, I squared is equivalent to -1. So we have -21 times 10 is equivalent to, -21 plus 10, that is -11. And then we have 14 plus 15, that is positive 29i. So this is already our final answer. Now we'll move on to the discussion of the division of our complex numbers. So again, in the division of complex numbers, you need to multiply that one with the conjugate of our denominator. So we have 5 minus 3i divided by 5 minus 3i. And then perform the operations. So we have 2 times 5 plus 2 times -3i plus 4i times 5 plus 4i times -3i. Then we have divide that one with our denominator. So we have 5 times 5 plus 5 times -3i plus 3i multiplied by 5 plus 3i multiplied by -3i. So that gives us equivalent to 10 plus, sorry, that should be minus. So we have 2 times -3, that is minus 6i plus 20i minus 12i squared. And again, I squared is equivalent to -1. So we can just replace that with -1. Now for the denominator, we have 25 minus 15i plus 15i minus 9i squared. And again, I squared is equivalent to -1. So we have -12 times -1, that is positive 12, plus 10. So we have 22 minus, 6i plus -6i plus 20i, that is positive 14i. And then we have the denominator, -9 times -1, that is positive 9. 25 plus 9, because this one is cancelled because this will result to 0. So 25 plus 9, that is equivalent to 34. And we know that we can still simplify this one. So this will give us the value of 11 over 17 plus 7 over 17i. So this is now the final answer of our complex, or the division of our complex numbers. So those were all the things that we'll be discussing in this video. I'll see you in the next video.